Hello friends, welcome to the third video in STM tutorial. In this video, we will be interfacing the 6x6 LED matrix with STM32 controller. Place the STM controller in the sheet area. Now select yellow LED and place it in sheet area. After you place the LED, double click on the yellow LED. Select the model type as digital and set the forward voltage as 1.2 volt. As you set the forward voltage, click on the hidden box in front of yellow LED. It will hide the text yellow LED. Now copy and paste the yellow LED. Copy these two LEDs and paste it to the side. Again paste the two LEDs to the side so that we have 6 LEDs in a row. Now we will connect anode of all LEDs. I have connected anode of first and sixth LED together. After that, connect all the anodes. Now copy this LED structure and paste it below. Repeat this step again so that we have total 6 rows. Now that we have total 6 rows, let's connect the columns. Now I am connecting cathode of D1 with D31. Just double click on cathode of D2. It will automatically create a connection between D2 and D32. Repeat this for D3, D4, D5 and D6. So the cathode will be connected automatically. Now connect the cathode of D7 to the cathode of D1. Repeat this step for D13, D19, D25. Let's repeat this step for column 2, column 3, column 4, column 5 and column 6 LEDs. Our LED matrix connection is ready. Now let's take anode connections out. We have total 6 rows of anode connection. Now let's take column connections out. We have total 6 number of columns. So there will be 6 connections for cathode columns. As we go on increasing the LED matrix size, the number of pins of STM controllers available to us becomes less. We have taken rows and columns connections out. The solution for pin optimization is to use demultiplexer. So we will select demultiplexer. We have total 6 rows and 6 columns. So we will be selecting 3:8 demultiplexer. Select 74SC238 non-inverting demultiplexer, which is 3:8 demultiplexer. After selecting the demultiplexer, place it on sheet area. Once you place the demultiplexer, double click on it and click on XY mirror. Connect the output pins of demultiplexer with row connections. Now as you can see on the right hand side there is ABC connection and E1, E2, E3 connection. Let's connect A with PA0, B with PA1 and C with PA2. As you can notice that E1 and E2 are active low inputs. So we will connect those two signals to the ground. And connect E3 to the power. The reason for selecting the non-inverting demultiplexer will be given in a minute. Now select the demultiplexer with inverting output. Select 74SC138 and place it on sheet. Repeat the same procedure for XY mirror. Now connect output of 74138 to column connections. So we will be connecting it one by one. E2 and E3 are connected to ground. And E1 of 74138 is connected to power. Let's connect ABC of 74138 to PA3, PA4 and PA5. Our connections are done. Let's select the properties for VCC and ground. For that, click on Design, click on Ground, add VSSA to the ground. Select VCC and VDD from the name toolbar, set the voltage as 3.3 volt, add VDD8 to nets connected to VCC. Open the STM32 CubeMX software to edit the pin functionalities. Select New Project. Select STM32F103C6. In the window, zoom in on STM controller. Go to System Core and select on RCC. To the right hand side, you will see high speed HSE clock. The HSE is for selecting external crystal oscillator. For our simulation, we do not need external clock source, so we are disabling it. Go to clock configuration. So we will select internal clock source for system clock mux. GPIO operations and other peripheral operations are all dependent on the system clock source, which is set on internal clock source. Coming back to pinout and configuration, we will now set the GPIO functionalities of PA0, PA1, PA2, PA3, PA4 and PA5 as GPIO output. For that, you have to click on the GPIO pin, select GPIO output, repeat it for PA1, PA2, PA3, PA4 and PA5. Once the pin functionalities are set as GPIO output, we will go to next step, that is Project Manager. Give project name, select the project location. I have already set the project location. Select the toolchain as MDK arm. Once all is set, click on Generate Code. Once the code is generated, it will redirect to open the Kill IDE. Open the Kill IDE, click on Application and Users. Double click on Main File. The main file will open. Scroll down so that we will come to while loop. This is where we edit the code. So we will write GPIO output pin functionalities for accessing the LED. I have already written the code for you. We have to set the respective anode row to high logic, that is logic 1. That's why we have used non-inverting demultiplexer. Now open the datasheet for 74238. As you can see on the datasheet, I have already highlighted some text. When all three select inputs are low, output Y0 will give us high. A0, A1 and A2 must be set to low to select the first row. We have written the GPIO functionality. So we have used GPIO write pin function to set the GPIO 0, 1, 2 to logic low. For second row, we have to set A0 to logic high. So we have set GPIO pin 0 to logic high. For row 3, we have to set A0 low and A1 high. Pin 0 is reset. Pin 1 is set to logic high. We have to write the same code for 4th, 5th and 6th row. Open 74HC138. To select the first column, we have to set all three select inputs to logic low. We have written a small function for column selection. So we have set all three inputs of 74138 to logic low. To select the second column, we have to set A0 of 74138 to logic high. We have set GPIO pin 3 to logic high for selecting the second column. For selecting third column, we have to set A0 to low and A1 to high. We have reset GPIO pin 3 and GPIO pin 4 to set. Similarly, you have to write the code for 4th, 5th and 6th column. I have already written the code. Now let's build the code. Once the code is built, the hex file will be generated in the code directory. It will take some time. Now let's load the code into controller. Go to directory, select the hex file and click on open. Now let's run the code. We are successful in glowing the LED sequentially in 6x6 LED matrix, and we have achieved it with less GPIO pins. Using the similar technique, you can go on increasing the LED matrix with less number of GPIO pins. If you enjoy the video, hit like, share and subscribe.